Atoms can neither be created nor destroyed. And we know all compounds are made of atoms. In a chemical reaction, when compounds react together, the same number of each type of atoms appears on the product side. What actually happens during a chemical reaction? Bonds are broken and new bonds are formed. This reformation of new bonds creates new compounds. We represent the reaction between reactants to produce new compounds, products, using chemical equations. Sometimes the chemical equation is not balanced. The number of atoms of each element on the reactant side is not equal to the product side. This is when we need to balance the chemical equations. Let's look at this equation, the reaction of hydrogen with oxygen to produce water, H2 plus O2, to give H2O. If you count the hydrogens on the reactant side, we have 2 hydrogens, and on the product side, we have also 2 hydrogens. Now, if we count the oxygens on the reactant side, we have 2 oxygens, but on the product side, we have only one single oxygen. To balance the equation, we can multiply the product side by 2. By that, we have 2 oxygens, but also we have 4 hydrogens, not 2. To keep the whole equation balanced, we multiply the hydrogens on the reactant side by 2. Now we have 4 hydrogens on both sides. Let's balance this equation, the reaction of iron 3 oxide with carbon monoxide to give iron metal and carbon dioxide. The first step is to count the atoms of each element on each side. There are 2 iron ions on the reactant side and 1 iron atom on the product side. For carbons, there are 1 and 1 on both sides. There are 4 oxygens on the reactant side and 2 on the product side. The second step is to balance the element that appears once on each side. Let's balance the iron by multiplying the iron on the product side by 2. Moving to balance the oxygens, we multiply the carbon monoxide by 3 and the carbon dioxide by 3 as well. Now we have 6 oxygens on the reactant side and 6 oxygens on the product side. Notice the carbon now on both sides is balanced. On the reactant side, there are 3 carbons, and on the product side, there are 3 carbons as well. Let's look at this exercise. Write a balanced equation for the following reaction. Iron reacts with hydrochloric acid to form iron 2 chloride, FeCl2, and hydrogen gas. First, we write the equation Fe plus HCl to give FeCl2 plus H2. Second, we count the atoms on both sides. At the reactant side, there are 1 iron, 1 hydrogen, and 1 chloride ion. At the product side, 1 iron, 2 chlorides, and 2 hydrogens. Third, we balance the iron. We have 1 on the reactant side and 1 on the product side. Fourth, we balance the chloride ions. 1 on the reactant side and 2 on the product side, so we multiply HCl by 2. Notice, by that the hydrogens were balanced as well. 2 at the reactant side and 2 at the product side. In some chemical reactions, especially in chemical equilibrium reactions, it is important to specify the physical state of the reactants and the products. The state of each compound is written between 2 braces in abbreviated form. The abbreviated symbols for each state: S for solid, L for liquid, G for gas, and AQ for aqueous solution. For example, here we have the reaction of zinc carbonate with sulfuric acid to give zinc sulfate, water, and carbon dioxide. You can see the zinc carbonate has the S symbol, which indicates that zinc carbonate is solid. Sulfuric acid is an aqueous solution. Zinc sulfate is an aqueous solution as well. Water has the liquid symbol and the carbon dioxide has the gas symbol. Let's solve this exercise. Write a balanced chemical equation including state symbols for the following reaction. Solid calcium carbonate reacts with the aqueous hydrochloric acid to form water, carbon dioxide, and an aqueous solution of calcium chloride. First, calcium carbonate CaCO3 is sample for solid, hydrochloric acid HCl, and AQ sample for aqueous. To give, let's write first the major product, calcium chloride CaCl2, and again AQ for aqueous. Notice we wrote Cl2, not just Cl, because calcium is divalent and chlorine is monovalent. Water H2O and L for liquid, and carbon dioxide CO2 and G for gas. Now you can see that for balancing the chemical equation, we need to multiply the hydrochloric acid by 2.